Today, we'll demonstrate two ways how to find package dependencies of a Go package. So first, some introduction. What are package dependencies and module dependencies? Well, package dependencies are the imports, the things you import at the top of the file. If your Go compiler cannot find or compile these package dependencies, then you can't compile your package. On the other hand, module dependencies are dependencies on a module, and a module is a collection of typically related Go packages that are versions together. And you declare your module dependencies in your Go mod file you see over here. And this could contain, each module could contain tons of packages, and you may only be using one of those packages. And then the modules, of course, have their own dependencies. And you can see kind of indirect dependencies also mentioned in your Go mod file. All right, so why are package dependencies important? Well, it's vital to understand your package dependencies for several reasons. One is they indicate the amount of internal coupling in your code base. Two, they help you understand the structure of your code base. Three, they help you avoid too many dependencies. And four, they help you avoid circular dependencies, which are especially annoying when you're just trying to write some code and all of a sudden you can't import a package because it creates a circular dependency. And lastly, they can help you optimize your build times. So basically, as your code base grows, keeping track of your package dependencies is important to ensure that your code base remains maintainable, right? It's very easy to just import dependencies without considering the consequences too much, right? In a modern IDE, like I just demonstrated in Golang, there's a pop-up that comes up and you simply click import and it makes your squiggly lines go away. And in some cases, I recall that sometimes it just imports packages without even asking me. However, the code with too many dependencies becomes coupled. Potentially unrelated code is coupled together, and this entanglement makes the code base harder to understand, harder to test, and harder to maintain. In my previous video on evolutionary architecture, I kind of detailed a list of issues. All right, so we're gonna use an example where we will check to ensure that our Go package is not dependent on another package in our code base. This is what's called an architectural test, right? An architectural test makes sure your code follows the architectural rules that you have defined. And this is one way that you can prevent your code base from devolving into a big ball of mud, right? Architectural tests are or help keep your code base clean. All right, so let's jump into the first way of finding package dependencies. We're going to use the command line. We're going to use the go list command. Looks like I can make this bigger. Make it even bigger. Okay. So go list -deps for dependencies, and then I simply point to a package, either a single package, or I can use ... to get all the sub packages. So let's go ahead and run this, and it gives me this pretty large list, right, of dependencies. And this is typical, and this package directory is not even that big. I could filter out, right? There are some kind of runtime metrics, some kind of standard library packages here, so I could filter those out. And maybe I want to sort this as well so it's easier to read. So let's go ahead and do that. So I use the previous command, then I pipe it to grep. So to identify what's a standard library package and what's not, we can see that the non-standard library packages have a dot in them. So we're going to use this pattern. So we're going to say caret -e for regular expression, caret, and then we're going to say basically anything except a forward slash can happen. Then we're gonna look for a dot, and then we're gonna say anything except a forward slash, and then we're gonna say forward slash, and we'll sort that. Okay, so now we've got our packages sorted. That's pretty nice. So we can kind of like analyze to see what kind of stuff we're importing. But in order to add an architectural check, we want to make sure that we're not importing some specific package, or maybe we want to have multiple architectural tests to check that we're not importing a bunch of packages. So let's do that. So grep by default returns 0 if the check is if it finds something. But in this case, if we find something, we want it to return a 1, right? We want it to be a fail. So we use not, and then we list our dependencies, just as I did before. And then we use grep -q for quiet, and then we list some package that we don't want to see. So in our case, I have one prepared that I'll just copy and paste. And then we close. So ideally, I don't want to see this, but in this case, it will fail. So let me go ahead and run this. And then I check the exit code. And the exit code is 1, meaning my architectural test failed. So this is a nice one-liner that you can add to your CI/CD pipeline. And then, if you can use shell scripts to pass in an array, or just do a 1 line per package to do this check. So that's one way. You can simply use command line. It's pretty straightforward. But we like writing Go code, so let's jump into another way, is where we're gonna actually write a unit test that will do this check. Let's go ahead. So we're gonna use a couple of things here. We're gonna use this Go packages package, and then we're gonna use this build package. So let's go through this test and kind of show you what it does. So I've got a single test here, test package dependencies. This is my package name, and I could expand it like I did before with a ... here, or I guess go up and do ... up here. But in this case, I'll just do this as an example. And then in here, I am saying that this package should not depend on these other packages. And here I'm listing a specific package, and here I'm also using this ... expansion to get all the kind of sub packages from that directory. All right, so let's jump into the test. So new package test. This is just a factory pattern that just returns package test, and then we're calling should not depend on. So first we expand packages on what we passed in. In our case, we didn't pass in anything to ... so it doesn't need to be expanded. So I'm going to skip that for now. And then we have this loop to find dependencies. So let's see what find dependencies does. We create a channel, so it actually creates a channel. So it actually returns a channel. So we effectively loop range over the results from this channel. Let's go ahead. We have a cache, which is looks like a set. And then we call expand packages. Expand packages on what? Our packages. Let me go back, just to make sure. New package, should not depend on packages. Okay. All right, this is the expanded packages is what we should not depend on, and this packages is our package. So we find dependencies of our packages. We will expand our packages. This needs expansion is just a check for ... over here. And here's where we use that load function from the packages package. We load using need name, and we get loaded packages. And essentially the thing where we're extracting from here is the package path, but this packages struct contains a bunch of other stuff. One thing of interest here may be the, let me see. Okay. Yeah, it contains a bunch of other stuff. Okay, so we get expand packages, we get a list of paths. Let's jump back. Find dependency, expand packages, and then for each package, we read it. So the reason we read it is to get dependencies of dependencies, right? So we have a queue here. And as we find more dependencies, we push them back onto the queue. And then each time through this loop, we examine the thing in the front of the queue, right? So we push back the top dependencies. Then we pop the thing off the queue. If we already seen these dependencies, we skip it, or if the dependencies is the C dependency, we also skip it. Otherwise, we add it to our set, right? This set indicates what we've processed already, and then we write it to that channel. And remember, early on, we are ranging off that channel, right? We add it to that channel so that the next calculation can proceed. Meanwhile, we go ahead and you call this context import, which is the build.default import. So that imports everything that's dependent on this package. And for these packages, we push them back to the queue. Let me see, is this the same? Okay, this is, all right, this is the package struct. Okay, this is an interesting one. It has a bunch of things here. And this is kind of the same struct you can have access to with the previous go list command. So you could also look at the test go files here. So you could examine the test files as well. Going back, so we could, besides for just imports here, we can add the test imports. So over here, test imports. Push them back to the queue. All right, so this processes all the dependencies. So let's go back and see what we do with them. For each one of them, we just call is dependency on, and yeah, and it's just a contains check here. And then we error, so we will only print the first error, right? If we find a package that fails this check, but we can have multiple, we can be checking for multiple packages, right? So say we have 10 packages here, 5 of them fail, so there's going to be 5 error messages. All right, and the link to the code is in the article on the bottom of this video. So thanks for watching.